Welcome to another teardown video. This time it's a PROMAX RP 100. It's a return path multi-carrier generator. And there's a charge. And we got input and output connectors. 75 ohms, yep. And this is the Q model. So the Q means it's 4 carriers. So this is the top model. And over here we got USB is 10 to 14 volts DC and a contrast potmeter. This is 10 to 14 volts. But here it's only 12 to 14. So they don't really agree. So I think we should try and give it 12. Yes, and what not? So that was charge lamp is on, and okay, 12 volts and a quarter of an amp. So that's 3 amps. Oh, it's dropping. So that is yes. Okay, current is dropping, so that means there's a battery that we are charging, and so when voltage is rising, current goes down. Well, that means the battery is actually taking energy, right? I did search a little bit on the internet. So this thing is capable of generating 4 carriers from 5 to 100 megahertz. So here's what I did. I took a spectrum analyzer and set for 5 megahertz and 110. Okay, so this is the I guess this is the output, right? Yeah, arrow out of a round thing, that must be the output, right? And turn on. It looks like the CPU in this one is not running at super high speed. Did you guys see this? Let's try and do that again. Okay, now I turn the unit on. Really? Oi. So that's the 4 frequencies and the output power, and they're on, and that's not logic, is it? I go down and this one goes up. Oh, damn it. And then one push, and then I'm here. So I dial up, then I dial down. Okay, now it works. I dial down, good, and then I go up. Yes, yes. Okay, so now it seems to be working, right? And then one more click. Okay, so that will be the and again, so I can set it up real accurate. And the power. And okay, so I turned it off. Oh, okay, that's smart. It actually follows. I think it actually does this live. Let's take another one that is turned on. So this is the 69. Click one and then 65. Yes, it is. See? Here we go. That will be the 3 channels that's on. And if I So that will be 10 megahertz per step. Okay, good. So let's click one click, and then that will be the ones. Is it moving? Ah, damn it. It only moves after a little while. Can you hear this? Says click, 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 and then see? So I have to wait. Okay, that is funny. Funny user interface. It's not supposed to be fast or anything. You're just supposed to set up the carriers. But anyway, it seems like it's working. And what I got here is... oh, this screen is impossible to read. What on earth? 62 megahertz. Let's take that one and say peak. Yeah, 62.1. So that is quite close. And the dBm millivolts is 47, but it's also a 50 ohm machine, and this is also a 50 ohm cable. This is a 75 ohm output, and this one is probably calibrated to the 50 dB millivolt in 75 ohms. So that explains why I'm reading a little bit too low. Alright, so it seems to be working, and it's a little bit really a dodgy user interface. I must say I didn't spend more than 2 seconds figuring this out, so it could be just me. If you spent 5 more minutes, it was probably gonna be fantastic. I can't say that, but let's just open it. Teardown time, yay! So let's. Why is this not coming off? Okay, we are in, and now it actually turns out there's actually light in the display. Let's turn off the... Why don't you turn off? This is off. Let's turn off the light here. Ooh, look at that. There's actually light. That's actually... Can you hear this? That is there. The light generator is screaming. Or... There's a switch mode power supply. Okay, let's turn on the light again. So that's a funny switch mode converter there. That is a cool. And there's a big nasty battery in here. And that will be the 4 generators and maybe a buffer amplifiers or something. Ooh, yo. They are warm. Okay, this explains maybe the power usage is 11 watts. You kidding me? So this is why they're warm. And there's also the input and output system here is also active with a buffer amplifier or something down there, because I can see that if I put in another signal into, oops, come closer, into the input. Here we go. Come on. So that was the input, and then we... Ding. So that was the other frequency. So this is the frequency I input. And if I turn off this unit, see, my output goes off as well. There's only this little weak... so let's turn it on, and then... DVD communication, wakey. Then they kind of start. That's funny. So this is annoying. This is the contrast. Oh yeah, that actually makes the display really good. So it's always a good idea to adjust the displays. Pretty nice. And you should also be aware not to touch anything here. You need to know what you're doing, because you can get electrical shock from this thing. So anyway, there's an EEPROM with the software. And where's the CPU? Most likely an SMD thing on the bottom. Oh, I think we should open the bottom and see what is hiding. Yeah, let's do that. So this is the back side of the unit. And this is this sexy transformator system with some diodes and simple switchers. So this is a simple switcher doing whatever it's doing with this, and a 5-volt linear regulator. And it looks a lot like hand soldering. Yikes. Everything here is hand soldered. Really? Even the SMD components? That is crazy. So it looks like a prototype. Is this really the kind of quality level? And they didn't clean anything. So that will be all the line drivers for all the communication to all these. And they really mean some serious business with EMC. Look at that. That is done in a really good way with the feed through. Solder side, yes. What else can we say? Let's look at that. So that's easier to see. It looks a little bit like 5 identical units, more or less. When it comes to pinouts, we got some few data lines and some stuff. The PCB layout look fairly normal and all that. It could be a, of course it's a 4 or 6 layers, especially when I see stuff like this. Then I know we got a lot of layers. And then, oh, look at that. So they mean business with EMC shielding. And also there's a little metal, or is this a PCB as well? I need to go in those cases and have a look. And there's another little feed through here, but it's not that bad. I was looking for some identifications. So what does this say? Yada yada 50 and 17, whatever that is. So I removed the battery holder. I was looking for a CPU of some sort. Oh, and this. So they needed more layers. So the layers inside the PCB is not enough. So okay, let's add a few more layers like this and just use those pins to connect them. That is actually a smart way to add more layers. So that means we're dealing with a lower layer count in the big and expensive PCB. That is not so dumb. In the USB area, and we got a chassis brake. So all this ground here is not this ground, and the power supply area here is isolated ground plane. That could be a good idea, yes. All this is an isolated ground plane, probably here we're jumping over, and there is an inductor. We go over there. So this is really smart. We got the power supply in here. Again, probably through a fuse and diode. Yeah. Well, look at those hand solder jobs all over the place. How can it must have been a prototype. This can't be how you manufacture high volume stuff. So let's get in the shielded case here. This is a case that is underneath this entire area. Now we're inside. So we've got some RF amplifiers and some mixers, or maybe just frequency combiners or something like that, right? Yeah, not a big thing. That is quite close to what I expected. I was hoping to see just 4 just resistive dividers. I'm trying to get the board out, so there's also a regulator down here, and look at this. That's pretty neat. So a little piece of aluminium underneath the regulator here. So that means you don't need to play around with bending the legs, and it's never gonna work, and you're never gonna get the angle right and all that. And also, I think I found the CPU. It is that one. We need to clean this up and figure out what that is. Well, that looks nice. I love those EEPROM microcontrollers. Ooh, this is expensive. And this is a really nice encoder with a push button in it. I like that. So at least that is good. And the display is quite good as well. The backlight is getting really dim, but that can be salvaged and reused. I can't really use anything else in this one. All those generators aren't really that accurate or anything useful for anything. They can't be modulated or anything cool, so that is not real. And they can't really do anything that you can't do with a $10 generator off eBay anyway, so yeah. And that was the copper tape over the holes you need to access to solder the connectors. And see this, how this is mounted with the 3 screws like this, and they were supposed to hit this groove, but they're standing just on the edge. So that is a little bit funny. And how are you gonna access the screws? You need to take out the PCB, so that is mounted first. The case is made in one piece and simply bent like this, and the front is just one of these sticky plastics, and here is the glass that is just glued on the back. It's a little bit thicker and more. It's actually quite nice because it's supported all the way around. It's not that thick or anything. So that is a really good way to do it. And now I got the whole thing out. I can see there's a temperature sensor down there, because those modules do run quite warm, but they are in a socket. Look at that. I think that will be a socket, right? So we should be able to take the modules out and inspect. And also it looks like sockets. Some are soldered and some are... Oh, this is a socket, right? Yes. Ooh, MCX. Yay. Okay, so we got MCX connectors for some of them. Ah, look at that. That is how it works. So how do we get this out? So this is the CPU ST62E30BF1. It's a beautiful chip. If only I had a real crazy macro. Yep, that was easy. Took only a few seconds to solder these out. Easy. And this is why people with a mid-cal Just love this. I always laugh at how easy it is to desolder stuff like that. It could have been difficult if you were using a weak soldering iron, because look at all this copper that's directly connected to all this. Ooh, it could have been difficult. But with a Metcal, it just takes stuff out, you know. Easy, easy. Hey, let's see what's in those modules. This is inside the 5 modules. We got 4 identical and 1 unique. So let's first look at the identical ones. So we just see one of them here. And this is the one that covers 5 megahertz to 100 megahertz of output. So there's of course a local 5-volt regulator. We got a serial input I/O chip, and we got the AT260, so that will be the attenuator. And we got output amplifier. We got all the different bands, 6 different frequency bands. So we got filters to handle that. We got the what is that? That is a PLL, right? So that will be the PLL, and we got the inductor up here for, yes, indeed, the oscillator. And there will be a little diode up there. So this is the oscillator. And yeah, so output from the oscillator goes again via all the different bands that can be selected via pin diodes, I guess, right? So, and they will be biased via the transistor system here, and all this inductors and filters and stuff for the different bands on the other side. Yeah. So that is basically why it performs so well. It really generates nice and clean outputs without any spuriouses or any other bad stuff. And that's of course because we got all those nice filters. So that is really, I'm impressed. This is super good design. Okay, it looks a little bit hand soldered and all that, but it's really nice. So there's another one that is a little bit special. So there's another type of synth, and so this is again the same oscillator they're using. And up here we got the oscillator components, and so this is, I think there's an input on output extra here. So this is probably a reference, but it's also there's also 4 megahertz reference here, and it's also input output here. So that's a little bit confusing what this one is doing. We can see the output. This is the oscillator, right? So the oscillator goes in here, the output from the synth goes into this bad boy, and this is of course was blown. So it takes the series resistor. That's a classic problem. But yeah, beautiful hand soldered prototype. Yeah. But I got a few of these, so it just didn't really matter to sacrifice one to make a nice video so we could see exactly how it was done. Maybe we can use some of those amplifiers for something. I'm definitely gonna look up some of those parts because I can't get any parts for prototypes and stuff. So it's always fun to save some of those boards. One day I need some funny stuff. What I do is a lot of funny prototypes every day, so always cool to have some stuff on stock. Oh yeah, I also found this. This is infrared receiver. So in the front, see, there was a secret hole here next to the charging lamp. So it can definitely be remote controlled. So that was quite funny to see. So thank you for watching.